Imagine if humanity finally unlocked the power to bend space-time and solve the mystery of how to craft the long-dreamed warp bubble that would allow us to travel faster than light. After years of imagination and experimentation, we were able to create a vessel capable of folding the universe around it, shrinking the vast distances between stars into manageable journeys. But what if this magnificent and awe-inspiring bubble, a triumph of physics and ingenuity, suddenly collapsed? Could we survive such an event, or would it unleash forces beyond comprehension, destroying not only the ship, but perhaps tearing apart everything around it? The promise of warp travel comes with awesome, unimaginable risks, and the potential consequences of failure could be catastrophic. What would happen if a warp bubble suddenly collapsed? To understand what happens if a warp bubble collapses, let's start with what a warp bubble is supposed to do. In theory, it's a field of distorted space-time, compressing space in front of a spacecraft while expanding it behind. The vessel sits in a pocket of flat space-time, insulated from the effects of faster-than-light travel. Essentially, it doesn't move through space, it moves space itself, sidestepping the universal speed limit imposed by Einstein's theory of relativity. It's a concept that sounds elegant and straightforward, but achieving it would involve manipulating exotic physics on a massive scale. This brings us to the first problem: creating the bubble in the first place. The theoretical framework of a warp drive, like the Alcubierre drive, requires exotic matter with negative energy density, a material that behaves in ways completely opposite to anything we've observed in nature. Even if we found such material, we would have to convert a planet the size of Jupiter into pure energy, or even as much as the total energy output of our sun over its lifetime. Then, maintaining the stability of that warp bubble would be an entirely different challenge. Why? Because space-time is an inherently chaotic and unpredictable medium, and any disturbance in the balance of the bubble could lead to its collapse. So, what happens if a warp bubble collapses? The short answer is no one really knows, but the possibilities based on our understanding of physics are most probably terrifying. For starters, a collapsing bubble would release enormous amounts of energy, the massive amount that was used to create it in the first place. Warp bubbles rely on the manipulation of space-time, which means they're operating at the very limits of what's physically possible. If the bubble were to destabilize, the stored energy in the warped space-time would most likely be released in a catastrophic burst. This explosion would obliterate the spacecraft and anything nearby, essentially vaporizing it in an instant. But the full consequences of a collapsing warp bubble wouldn't stop there. The energy release would ripple outwards, distorting space-time in unpredictable ways. Nearby celestial objects, from planets to stars, would most certainly feel the effects. How much would depend on their distance. Imagine creating a massive space-time quake that reverberates through the universe, altering gravitational fields or even creating tiny black holes. These black holes, though small, would grow by consuming nearby matter, becoming long-lasting and unintended byproducts of the massive amount of stored energy within the bubble. Then there's the possibility of radiation. Theories suggest that a collapsing warp bubble would unleash a deadly burst of high-energy particles such as gamma rays. These particles, accelerated to near light speeds, would devastate the surrounding region of space. If a spacecraft equipped with a warp drive were anywhere near a habitable planet or star system, the collapse would cause widespread destruction, sterilizing entire planets with radiation, wiping out entire planetary systems on a massive scale. A failed warp experiment would leave a legacy of interstellar destruction, branding humanity as a race of reckless explorers and overzealous dreamers. Another fascinating yet horrifying possibility involves causality. Warp bubbles, by their very nature, challenge the normal flow of cause and effect. They bend space-time in ways that could, theoretically, allow for time loops or paradoxes. If a bubble collapses, it might not just release energy, it could also disrupt the linear flow of time itself. Imagine the bubble's collapse, creating a localized zone where time behaves unpredictably, looping or reversing in bizarre ways. The result could be a region of space permanently altered by the event, rendering it impassable or trapping objects in a temporal limbo. What would it mean for humanity to create a time scar in the universe, a place where even the laws of physics no longer apply? It's something that's very real, and the possibility of it may be reason enough not to attempt the creation of a warp drive in the first place. But perhaps the most chilling possibility lies in the unknown. A warp bubble interacts with space-time in ways we can only begin to theorize, and space-time itself most likely contains properties we haven't yet discovered. If a bubble were to collapse, it could potentially rip through the very fabric of the universe, creating tears or anomalies that extend beyond our ability to control or repair. Could a single failed warp experiment trigger a chain reaction, destabilizing space-time across vast regions of the cosmos? It sounds like science fiction, but so did the idea of manipulating space-time in the first place. As for the crew, the collapse of a warp bubble would almost certainly be fatal to anyone aboard the spacecraft. The unimaginable forces involved would destroy the ship instantaneously, leaving no chance for escape or recovery. Even the insulated pocket of flat space-time where the ship resides wouldn't protect the crew if the bubble destabilized. They'd be at the mercy of forces so immense and incomprehensible that survival wouldn't even be a question. So, where does that leave us? The idea of creating a warp bubble is one of humanity's most ambitious dreams, representing our desire to explore the cosmos and push the boundaries of what's possible. But with such ambition comes extraordinary risk. A collapsed warp bubble isn't just a technical failure. It's a reminder of how little we understand about the universe and how dangerous it can be to tamper with the fundamental laws of physics. Regardless, the reality of creating a warp bubble remains a theoretical construct, one that exists only in equations and imaginations. But even in its theoretical state, it offers a glimpse into both the incredible possibilities and the sobering limitations of human innovation. If we ever do unlock the secrets of warp travel, we'll need to tread carefully, understanding that the universe is far more complex and far less forgiving than we might like to believe. Would the potential rewards of exploring the stars outweigh the dangers of a catastrophic failure? Or would catastrophic failure remind us of our fragility, keeping us grounded in a universe we're only beginning to comprehend? Do humans even have the right to experiment with the fabric of the universe on such a large and potentially destructive scale? Until we find these answers, the warp bubble remains both a concept that ignites our curiosity and a stark warning of what happens when we reach too far into the cosmos. I thank you for joining us on our theoretical exploration of what would happen if a warp bubble collapsed, and I invite you back for our next episode